chemical equilibrium was meant by equilibrium. In equilibrium, it refers to the reaction proceed in two directions to be
So
reversible.
this is which chapter?
Reversible means it proceeds in two directions, forward and backward reactions. Equilibrium takes place when the rate of forward reaction equal rate of backward or reverse reactions, and the concentration of reactants and the product is still constant or doesn't change. So no more longer change. And equilibrium affecting amount, not speed. How comes to be like that? Affecting amount, not speed. In rate, we said that the rate affecting speed, not amount, but in equilibrium affecting amount, not speed. If the reaction moves forward, this means that more yield is produced. What's meant by yield? Product. More yield is produced. And if the reaction moves backward or reverse, this means that less yield is produced.
What yields?
Product. So it depends on the direction, if the reaction moves forward or backward. As the reaction moves forward, this means that more yield or more product is produced, and if the reaction moves backward, it refers to less product or less yield is produced. And for the reaction to be reversible, we must have no product escaped. If we need the reaction to proceed in two directions to be a reversible reaction, we must have no product escaped as evaporate or precipitate. Like, for example, if we have N2 plus 3H2 gives 2NH3 in open container, this means that there is no reversible reaction, gas evolves. Or NaCl plus AgNO3 gives NaNO3 plus AgCl as a solid precipitate. So this means also no product, this one product escaped as precipitate or one product escaped as evaporate. But in case of N2 plus 3H2 gives 2NH3, reversible reaction in closed container. What's the difference between open and closed container? In case of open container, this means that gas evolves, while in closed container, this means that evaporation then condensation. After that, in case of equilibrium, there is factors affecting equilibrium. In equilibrium, reactance decreases gradually and products increases gradually until they reach equilibrium. So the reactance increases gradually and products increase gradually until they reach equilibrium. So we said equilibrium when the rate of forward reaction equal rate of backward reaction and the concentration of reactant product doesn't change. And there is factors affecting equilibrium. For factors affecting equilibrium, we have three factors: concentration, pressure, and temperature. In case of concentration, by increasing the concentration, the reaction moves from high concentration to low concentration. This is by increasing. So by increasing concentration, the reaction moves from high concentration to low concentration. By increasing pressure, the reaction moves from more number of moles to the less number of moles. By increasing temperature, it depends on the type of reaction, endothermic or exothermic. So the factors affecting equilibrium, we have three factors: concentration, pressure, and temperature. By increasing any factor and concentration, the reaction moves from high concentration to low concentration. For pressure, from more number of moles to the less number of moles. For temperature, it depends on the type of reaction, endothermic or exothermic. The first one, concentration. Concentration through liquid, pressure through gas. In concentration, for example, if you have a reaction CH3COOH plus C2H5OH to form CH3COOC2H5 plus H2O. This is an equation. How can we make the reaction moves forward? To make the reaction moves forward, this means that more yield. If we need it moves forward. How to move forward? By increasing reactants or decreasing products, the reaction moves forward and more yields produced. Again, we said that the concentration moves from high concentration to low concentration, okay? From high to low. So if we increasing reactants or lowering products, this means that the reaction moves forward. So if we are increasing CH3COOH or C2H5OH or decreasing CH3COOC2H5 or H2O, this means that the reaction moves forward and more yields produced. So what is the difference if we're increasing reactants or decreasing products? In case of increasing reactants, we have more yield and we have faster rates. As we know that by increasing any factor, temperature, pressure, concentration, catalyst, light, and surface area, the rate of reaction increases. So by increasing reactants, we have more yield and faster rate. But in case of decreasing products, we have more yield, but we have a slow rate. So the rate will be slower rate. Again, all of you concentrate. This is the equation that we have. In case of increasing reactants or decreasing or lowering concentration of the products, the reaction moves forward. What's meant by moves forward? It means that more yields produced. By increasing concentration of the reactants, we have more yield and faster rate because directly proportional, increasing concentration, increasing the rate. So we have now more yield and faster rate. While by lowering concentration of the products, so we have more yield but a slower rate. This is number one. Number two, pressure for gases. So concentration for liquids to be aqueous, while pressure for gases. And pressure, by increasing concentration, By increasing concentration of, by increasing the pressure, the reaction moves to the less number of moles. To the less number of moles, although forward or backward. So we have three cases. Number one, if the number of moles and reactants is greater than products. Like, for example, if we have N2 plus 3H2 gives 2NH3. How many moles in reactants? The coefficients that we have, 3 and 1, 4. And we must make sure that all of them are gases. If we have solid or liquid, we didn't count. We count only the gases for pressure for a gas. So 4 and 2. And make sure that all of them are gases. If we have, for example, there's a solid, didn't count. Okay, so 4 and 2. By increasing pressure, the reaction moves from more to less. So it moves forward. So if we're increasing the pressure, it moves forward. So if the reactants greater than products, so we are increasing pressure, the reaction moves forward. This is number one. Number two, if the number of moles in product is greater than reactants, so reactants is less than products. Like if we have 2SO3 gas 2SO2 plus O2. How many number of moles? 2. What is the number of moles? 3. If we are increasing pressure, what will happen? It moves from 3 to 2, so it moves backwards. If we're increasing, it moves from high to low, from more to less, so it moves backward. If we change that we are lowering, it moves from 2 to 3. So if we are adding these 2 and these 3, we have two cases. If we're increasing the pressure, it moves from high to low, moves backwards. If we are lowering from 2 to 3, forward. So in this case, if we need more yield, so we need to make it decreases to make it moves forward. What will happen if we increase, it moves backward? What is the difference between forward and backward? Forward, it means more yield. Backward, it means less yield. The third option that we have, if the number of moles reactants equal products, like H2 plus I2 gives 2HI. 2 moles and 2 moles. Pressure doesn't affect. Why? Equal number of moles in both sides, so equilibrium takes place. So again, in pressure, we have three cases. If the number of moles in reactants is greater than products, this is number one. If the number of moles in reactants less than products, if the number of moles are equal. The first one, if the number of moles in reactants is greater than products, this means that by increasing pressure, so the reaction moves forward and more yield is produced. And in this case, we have more yield and faster rates. Why we have more yield? The reaction moves forward. And why we have faster rate? Because we are increasing pressure. The second one, as the number of moles in product is greater than reactants, so must decrease or lowering to obtain more yield, to make it move forward. But we have a slow rates. If we are increasing to make it moves backward, in this case, this one, we have faster rates, but we have less yield. And we need to have more yield at the beginning. And third one, if the number of moves are equal, so equal number of moves, pressure doesn't affect. We have 2 and 2. No effect. Equal number of moves in both sides. So the first one, if the number of moves are reacting greater than product, we are increasing to make it move forward. If the number of moves in product is greater than reacting, we are lowering to make it move forward. If they are equal, doesn't affect. The third one, temperature. It depends on the type of reaction. If we have endothermic or exothermic reaction. An endothermic reaction, heat absorbs, heat is given, is taken. In exothermic reaction, heat is released, heat is given out. In endothermic, by increasing temperature, reaction moves forward. In exothermic, if we are lowering, moves forward, and if we are increasing, moves backward. Like, for example, if we have H2 plus I2 plus heat to gives to HI. This means that the reaction is endothermic, so require more amount of energy. So by increasing temperature, it moves forward as it is. While C plus O2 gives CO2 plus heat. This means that temperature is given out. No need for more temperature. We have excess of temperature, no need. So we are lowering to make it move forward. If we are increasing, moves backward. So how can we know this endothermic heat as a reactance or delta H equal positive? How can we know this exothermic heat as a product or delta H equal negative? So the summary for this part and concentration to make the reaction moves forward and concentration to increase the reactance or decrease product. And pressure. If the number of moles in reactants is greater than products, so we are increasing. If the number of moles in reactants less than products, so we are decreasing. If the reactants equal products, no effects. And temperature. If the reaction is endothermic, so we are adding to make it moves forward. If the reaction is exothermic, so we are lowering to make it moves forward. What is the advantage of moving forward? More yield. This is the advantage. And in case of increasing faster rate, decreasing slow rate, if we are increasing any option, this means that we have faster rate. If we are lowering a slower rate, this for the rate. For equilibrium, if it moves forward, more yield. If it moves backward, less yield. This for equilibrium. So equilibrium, it depends on the direction. Forward, more yield, backward, less yield. While the rate, increase, decrease, decrease. So for the rate, if we're increasing any factor, makes the reaction faster. And if we decrease any factor, slower. For the yield, if it moves forward, more yield. If it moves backward, less yield. Applications for equilibrium. We have Haber-Pros and contact-Pros. In Haber-Pros, preparation of ammonia, N2 plus 3H2 gives 2NH3. In contact, we have 2SO2 plus O2 gives 2SO3. Both reactions are reversible reactions. And both reactions are exothermic. The conditions for the reactions: temperature, pressure, and catalyst. Temperature 450 degrees Celsius. Pressure 200 atmospheric pressure and 2. Catalyst iron and vanadium pentoxide. For the conditions, we are using low temperature, high pressure, and we are adding catalysts. Explain why. Why we are using low temperature, why we are using high pressure, why we are adding catalysts.
Because it's exothermic, we need more yield.
This is right. For the first one, the reaction is exothermic. So by lowering temperature, the reaction moves forward and more yields produced. So the reaction is exothermic. So by lowering temperature, reaction moves forward and more yields produced. As we said, in case of exothermic reaction, we are lowering to make it moves forward. And pressure, we have number of moles of reactants greater than products, so must add. In Haber and contact, we have 4 moles, 2 moles, 3 moles, and 2 moles. So by increasing pressure, the reaction moves forward to the last number of moles. So why we are using high pressure, the number of moles and reactants is greater than product. So by increasing pressure, the reaction moves forward and more yields produced. Adding catalyst to speed up the reaction. Because in case of, if you are using, for example, anyone that we are decreasing to make it moves forward, we have more yield but slow rate. What is the improvement to increase rate by adding catalysts? So we are using catalysts to speed up the reaction. So in case of lowering, like lowering in concentration or lowering in pressure or lowering in temperature, what is the improvement to obtain more yield and a faster rate to speed up the reaction, to adding catalyst to speed up the reaction? Adam, you can read?
Consider the system below N2 plus 3H2 equilibrium with 2NH3. After the gaseous system has reached equilibrium, its total pressure has been reduced. What changes are expected to happen upon reducing the pressure of the equilibrium system? Select all that apply.
Okay, reducing pressure. Here we have 4 moles and 2 moles, 4 and 2. If we are increasing, the reaction moves forward. If we are reducing, so it moves backward. By reducing backward, the amount of NH3 will be less, and the amount of H2 and N2 will be more. So, okay, it moves. The backward reaction is favored. The pressure of NH3 is reduced. The system favors the formation of more H2. So again, in the first one, this is the equation. We have 4 moles and 2 moles. If we are increasing pressure, it moves forward. Decreasing moves backward. And then what will happen if we reduce the pressure? It moves backward. Okay. When it moves backward, this direction. So this means that this will be less and this will be more. If we have forward reaction, this means that this will be less and this will be more. If we have backward reaction with the direction of the arrow, this means that will be more and this will be less. Okay. Maya Amri, you can read?
Yes. Select the pictures that represent a system at equilibrium.
Equilibrium means evaporation and condensation, and the rate of forward equal rate of backward. They must be equal. The arrows here all moves down. The arrows moves up, but here the arrows moves up equals the arrows moves down. So evaporation, then condensation. Okay. Maya Ghazal, I read?
Yes, you can hear me.
Okay.
Which of the following are true about the system at equilibrium? Select all that apply. The macroscopic properties are constant. The forward and backward reactions take place at the same time at equal rates. The microscopic processes continue to occur, and both the reactants and products are present at equilibrium.
Okay. So we said that at equilibrium, rate of forward reaction equal rate of backward reaction, and the concentration of reactant product doesn't change, will be constant. So both reactant products are present at equilibrium. Criscopic continue to occur. So these are properties of equilibrium. As I said, properties constant, forward and backward reaction are equal rates. Microscopic process continue to occur. Both reactant products are present at equilibrium. These are properties of equilibrium. Okay, Ahmed Tajuddin, you can read.
Which of the following statements is true about the state of equilibrium? Select all that apply. A change in the amount of solid reactant in the reaction does not affect the equilibrium when Q more than K
Q is less
than
equilibrium.
K. The reaction proceeds to the right.
Okay, for this point, we said that for concentration, this for liquid, pressure, this for a gas, and nothing for solid. Solid means no effect. So here, a change of the amount of solid reactants and the reaction doesn't affect the equilibrium. So there is no effect for the solid because concentration affecting for liquid, pressure for a gas, no effect for solid. This is number one. Number two, when Q is less than Q equilibrium, this means that the reaction proceeds to the right, means forward.
I
So,
don't understand the last one.
okay, wait for a moment. For what's meant by Q? What's meant by Q?
Concentration.
Again,
Concentration.
not for concentration. Q refers to